That's what a cube looks like. Right? Now, just like a parabola, this is a pattern. This is your pattern. You find your starting point. Here, our starting point is 0, 0. It's over 1, up 1, over 1, down 1. Over 2, up 8, over 2, down 8. So instead of going in the same direction for both of them, we're going to kind of go in opposite directions. Okay? All right, so the process is exactly the same as parabolas. It's just a different pattern. Think about we're cubing the number. I always do it wrong. All right, so x cubed plus 2. So what do you think the starting point is? Think about the parabola. Yeah, there's nothing, and then it's positive 2. So that's your starting point, 0, 2. And then same process. Go over 1. What's 1 cubed? 1. Over 2. What's 2 cubed? 8. Go up 8. And then the opposite direction. Over 1. 1 cubed is 1, but you're going down this time. Over 2. 2 cubed is 8. So I'm at 6. This is 6. Negative 6. All right? And there's my cube. I keep wanting to say cubic. It's cube. And that's it. Okay? Number 3. Pause the video. Try this one on your own. Same process. All right. What's the vertex? The x value. Change the sign. 5 minus 5 is 0. 5, 0. Plot that point. 1, 2, 3, 4, 5. And then again, same process. I go over 1. 1 cubed is 1. Over 2. 2 cubed is 8. Over 1, down 1. Over 2, down 8. Okay? And try to don't make it lines. Try to make it as curved as you can. Okay? Try to make it as curved as you can. All right, 2 more of the cubes. Number 4. Pause the video. Try it on your own. What is the vertex? Switch the sign of the inside. -1. When you plug in -1, that gives you 0, and you're left with -4. That's your starting point. -1, -4. And then we're making our shift. Over 1, up 1. Over 2, up. 2 cubed is 8. 4, 6, 8. Over 1, down 1. And we can't really fit 8 on here, so we're going to have to estimate the best we can. So it looks like that. Okay. All right, last cubic. Pause the video. Try it on your own. Switch the sign of the inside. When you plug in 2, 2 minus 2 is 0, plus 4. 2, 4 is where we're starting. Over 2, up 4. Now, this one's a little different. What do you notice? Negative. So with a parabola, it flips it upside down. So what do you think this is going to look like flipped upside down? Yeah, instead of starting down and going up, we're going to start up and come down. So basically, imagine this thing is just flipped over. Okay? So when we go over 1, up 1, we're going to go left. Over 1, up 1. Now we can't go up 8, so now go down. Over 1, down 1. Over 2, let's see, 4, and 8. Okay. And that's it. Okay. You know, I'm a little off here, but that's okay. As long as you got a few points and it's the right idea. Okay? All right, so now let's move on. X to the 4th. What do you think is going to happen with x to the 4th? Take a magical guess where we start. 0, 0. Okay. So 0, 0. Let's do -1, -2, 1, 2. All right. -1 to the 4th. That's -1, -1, -1, -1, 1. -2 to the 4th. That's 16. Are we going to fit 16 on this graph? No. 1 to the 4th is 1. 16. Now, if you're raising something to the fourth power, can you have a negative? No. Basically, x to the fourth looks like a super skinny parabola. X to the fourth looks like a super skinny parabola. So all we're going to do is put those two and just make a really, really skinny parabola. It's all a basic, I mean, x to the fourth with like a real, if I had like an x cubed, x squared in there, yeah, it's not going to look like a parabola anymore, but the basic one does look like a parabola. And that's what we're focusing on today. Okay? All right, x to the fifth. Take a magical guess what's going to happen here. All right. xy, -2, -1, 0, 1, 2. All right. -2 to the fifth is -32. -1 to the fifth, that's going to be a -1, 0, 1, 32. Again, what do you want? What should we compare this one to? This one looks like x cubed, but it's more intense, right? It's the same idea as x to the fourth with x squared. They're gonna look similar when they're this basic, but it's just skinnier. They're just super skinny because they're going up so much faster. So we have our -1, -1, 0, 0, 1. Do not draw a line because you only have these 3 points. All right, so this one's like crazy skinny. It's like that. Okay, it's even more skinny than the x cubed. All right, so when the degree of a polynomial is even, the graph goes off. What do you think I'm looking for there? So all the even ones, x to the fourth, x squared, if we had x to the sixth, what happens to the ends of the polynomial? They go off in the same direction, right? They go off in the same direction. Okay.